Thank you, Eric. And good morning, everybody. Welcome, Caltrans. Very happy that you could be with us this morning. Today, we're going to be talking about the MASH terminal, the MSKT. And I would think by now that most of you are familiar with this. We are understanding that there is an ongoing program to replace some existing terminals, and the MSKT is one of those that is available. And what we wanted to do this morning is to focus on the inspection. As I said, I would think that most of you would be familiar with this system, but we're going to focus on the inspection part of it because as these replacements are being put in place, it is critically important that they are properly installed. I would also like to send out a thank you to Troy Bucko. He was very instrumental in allowing us to set this up. This presentation is being recorded. It will be made available in the next couple of days. We'll send a link out to Troy, and he will distribute that as he did the invitation for this morning's webinar. So again, we are going to focus on the inspection component as a part of this system. We would hope that those that are doing the installation are well schooled. We do offer training tools and installation manuals and such for the installation, and once it is installed, I know that one of the requirements of Caltrans is to fill out the inspection checklist, and that's going to be a big part of what we're going to talk about. So getting into the guts of the MSKT, I think the logical place to start is to be sure that you are all aware of our online training that we have for the MSKT. This online training focuses on proper installation and proper inspection of the MSKT. If you were to log on, this would be the first screen that you see. There are 6 lessons as part of the MSKT online training, and lesson 5 is really where the meat of the program is. That's where we talk about the installation and the inspection, and then once that's all completed, you are able to take a test and print out a certificate if you're able to pass the test. This online training is structured such that you have to get through every component, every part of each of the lessons before you're able to move on to the next. So this is a lot of what you'll see throughout the online training. This is a big focus of a lot of the lessons. It shows the system in a 3D configuration where there's a lot of things that you can do with the graphics. You can explode them or put the pieces back together again. You can rotate them in any direction, either in a assembled configuration or an exploded configuration. There's one thing that you are able to do in part of that lesson 5 is the installation. And the installation starts with a ground or a foundation where everything from post 3 downstream is already installed. Because post 3 up through post number 8 is standard steel guardrail posts, 6 foot long, standard block outs and standard rail. So there's really nothing different from post 3 and beyond. It's the first 12.5 feet that all of the unique components of the terminal is where that all occurs. So starting with a post 1 and 2 that need to be installed, what you do, you would go down to the directory below and you would select post number 2. You would click that, and then you would click where it goes. So this allows you to assemble it, and if you try to put the part in the wrong location, it will notify you of that. So as we have moved on, you can see now that upper posts 1 and 2 have now been installed, and the directory down at the bottom, once you properly install the piece, it shows that as a check mark. So if it doesn't have a check mark, it still needs to be installed. So getting further along in the online installation, you can see that the rail and the ground strut has now been added, and those are checked off. And Getting a little bit further, you can see there's only 2 parts yet that now need to be installed. That would be the bolts at the base of post 1 and post 2. And yes, you do not only need to install all of the parts correctly, you need to install the hardware correctly, as well as installing it at the proper location. And then once everything is completely installed, the directory at the bottom, everything is checked, it changed colors, and you get a green check mark to say the installation is now complete. And then once you complete the installation within lesson number 5, you then move on to the inspection. And the inspection is actually a visual checklist of what's in our installation manual. So we've broken up the installation manual into 4 sections within the online training. So what you would do is you select each of the items one at a time. And for example, if you were to select that first item, that's where the inspection starts. So the first thing that you're checking there is the rail height should be 31 inches plus or minus an inch above the edge of the finished grade. And you can see there that you can check that anywhere along the guardrail, and there's a picture to visually show you where to check each of the items as you're checking it on the checklist. So the second part of the checklist is there, moving on to the third, and then the fourth. So that is the complete installation checklist as it appears in our installation manual. That's part of the online training, where you physically have to check each of these one at a time, and you can't move on to the next lesson until you go through each and every one of these inspections. And then once you complete the installation and the inspection, that'll move you on to lesson 6, where you take the final exam. And if you're successful in passing the exam, it gives you an option to print out a certificate of completion indicating that you have successfully completed the MSKT online training. All right, now let's get into the details of the system itself. The first thing that we're going to mention is the impact head. You can see on the left is the NCHRP 350 impact head that is open. On the feeder chute end, you can see the rails, and it's very obvious the impact head on the right. The MSKT head is closed. We do have an FHWA letter, and we made the announcement some time ago that we are now only making the MSKT head. So that head can be used not only on the new MSKT systems, but as well as any NCHRP 350 systems. We very intentionally did not put MSKT on the head because we didn't want that impact head to show up on a 350 system and somebody think that it was an MSKT. So there are some other things besides the impact head. So just by simply using a MASH head on a 350 system, that does not convert it to a MASH system. Here you can see the MASH MSKT impact head, looking at it from the front and the back side. The head itself is very similar to the 350 system, but we did tweak it just a little bit. And of course, the obvious thing is we've enclosed it on the traffic side. You can see the differences there with the closed and the open feeder chute. So let's get into the pieces and the parts of the MASH MSKT as you're looking at it once it's installed. And again, we want to be sure that whoever's doing the inspection, that we confirm that the contractor has gotten it right on the install. So this was the first thing that we saw on our inspection checklist, that the impact head and the rail height are all correct at 31 inches plus or minus an inch. And then looking at it from the back side, you can see all of the components that make up the working parts of the MSKT. Starting at the top left is the impact head. The rail has not changed from the day that the technology in 1997 was introduced. The original NCHRP 350 SKT used the same rails as we're using today. So that's never changed. But note that there are some special slots. In the end, those are 1/2 by 4-inch long slots. The cable anchor bracket does need to be released. All of the hardware within the system, the post bolts, the splice bolts, those can all pass through the impact head as that head translates downstream, but the cable anchor bracket cannot. So we need to be sure that we have a release mechanism that's part of the design. And it's those special shoulder bolts that allow that to happen. The very critical part of the system. So on the installation and the inspection, we need to make sure that we have the proper shoulder bolts in place and that they're oriented correctly. We'll show you how that's done in just a bit. You can see that upper post number 2 has some open-ended slots facing the impact head, facing oncoming traffic. So on an end-on impact, post number 1 will break free, and post number 2 should pivot. If it's an end-on hit at a fairly shallow angle, post number 2 should pivot and lay down. So what that open-ended slot does is allows the post bolt to release from the post without tearing out any metal. There is a ground strut in the MASH version of the MSKT. That strut is not symmetrical. It has one long end and one short side. You can see at post number 2 that the forks of the ground strut need to extend to the far end of the post in order to attach that 3/4 bolt, because that 3/4 bolt is attached on the downstream end. And then on the ground strut, the attachment to post number 1 is the short side of the ground strut that only needs to span far enough to allow the post bolt to go through. There is a 5/8 bolt on lower post number 1 that attaches to upper post number 1, and that bolt is on the upstream side. So again, the 5/8 bolt on the upstream side of post number 1, the 3/4 bolt on the downstream side of post number 2. The bearing plate needs to be properly oriented with a 5-inch dimension up and the 3-inch dimension down, taken from the hole that the cable passes through. We do show a retainer tie should that cable become loose. The intent is to keep that bearing plate properly oriented. And those are the unique parts that make up the MSKT. On upper post number 1, one of the things that was added from the NCHRP 350 SKT to the MASH MSKT is that spacer angle. And what that does, it orients the bearing plate kind of at a negative angle, and that helps with our anchor capacity on the traffic face redirection hit. So that upper post number 1 has that spacer angle that is unique to the MSKT. This may look familiar to you. This is your standard sheet A77U5. This shows a transition from 28-inch guardrail to 38-inch guardrail. Now, the intent of the standard sheet was for guardrail, but this would apply if we're ever going to be attaching an MSKT 31-inch system to existing 28-inch guardrail, because there's two things we need to do as we make that attachment. We need to take the rail height 3 inches from 28 inches to 31 inches, and we also need to take the mid-span splice of the terminal down to an on-the-post splice of the existing rail. So if you're inspecting one of these and you have a 31-inch system attaching to a 28-inch system, we need to be sure that we gradually drop that rail height down 3 inches and we move the rail splice onto the post, as you see here. A very important part of any terminal is proper grading. When testing is done, it's done at an ideal condition, flat and level, and of course we don't have that in the real world. So what we need to do is create an environment for the terminal so that it can perform as it was tested, and we need to be sure that we can keep that vehicle stable prior to, during, and post-impact with the terminal. So this is a grading detail taken right out of the AASHTO Roadside Design Guide. So during installation, of course, during inspection, we need to make sure that we have a grading platform that allows this terminal to perform as it was designed and tested. So here you see a terminal in place, and it looks like somebody made an effort there to try to do some grading. But if you look at the environment, visualize yourself in a vehicle about to hit the end of that terminal. You've got the driver's side wheels up on the level, and you have the passenger side wheels halfway down the slope with that vehicle that's just probably nearly rolling over, and it's going to be very unstable. So if the vehicle is unstable, impacting the terminal is not going to stabilize the vehicle. It's only going to add to the instability, and this system will not perform as designed when you put it at a slope location, as you see here. Our installation manual, those are available online, and we not only talk about the proper installation, but we do address the grading part in the installation manual itself. You see here a wood post system. Most of the installations that we've seen across America is a steel post system where posts 1 and 2 are steel bolted, as you see here, and then the remaining posts 3 through 8 would be standard steel guardrail posts. And up to now, that's really what I've discussed, but I do want to make note that we do have the system that is available in a wood post option. In a wood post option, posts 3 through 8 would be breakaway CRT posts, the same 6-foot CRT posts that are currently being used. But even in the wood post system, the first 12-foot 6 stays the same. So there will always be those same 2 steel posts in post numbers 1 and 2. The second rail of the system is 9 foot 4.5, and we do that in order to create the mid-span splice within the terminal. You can see here in an installed steel post system all the unique parts that we've discussed up in the first 12-foot 6, your 9 foot 4 second rail that creates your mid-span splice, and then everything from post 3 and beyond being standard 6-foot guardrail posts. The system was tested with the rails straight. We do not permit any curved rail within the terminal, within the first 8 posts of the terminal. Now, if you are attaching to curved rail, you can attach the terminal to curved rail, but we can't include any of the curved rail within the terminal. And with our test level 3 system that we tested at 100 kilometers, that's the first 4 rails or up to the first 8 posts. Sometimes we see these installed at exit ramps or entrance ramps where the speeds are going to be lower and you have these tight radiuses. In a lower speed, anything lower than 70 kilometers or roughly 45 miles an hour, we only need 25 feet within the terminal. So it is possible to have everything from post 5 and beyond curved if we're in that lower speed. But for the most part, we'll be talking about the test level 3 where everything has to be straight. We do permit an offset. It is a straight offset anywhere between 0 to 2 feet, as you see here. And that's all shown in the installation manual, and you would want to account for that or at least allow that if you're doing the inspection. Here you can see the complete system below ground with your lower post 1 and 2. Lower posts 1 and 2 are 6 foot long, so we're going to have 6 feet of embedment. Every now and again, we run into situations where you hit rock, solid rock, or possibly electric lines, water lines, communication lines, and such. We do have an option to cut posts 1 and 2 if you do one of a couple of things, either drill directly into the rock or if you provide a concrete foundation. So we do have options. You can consult with us if you have a situation where that 6-foot embedment is not able to be achieved on posts 1 and 2. All the posts in the terminal, as you see here, are spaced at 6'3" centers. All of our unique parts that you can see here within the first 12'6" are upper and lower post numbers 1 and 2. Lower post number 1 has a soil plate. And when that is properly installed, that soil plate will be on the downstream side, as you see here. You wouldn't see this during inspection, but your installers certainly would see this before the posts are put into the ground. You can see lower post number 1. that has welded side plates that upper post number 1 rests into and where it gets bolted. Lower post number 1 is a 6 at 15-pound post. All the other posts in the terminal, upper and lower post 2, as well as standard posts 3 through 8, those are 6 at 8.5 pound, but lower post number 1 is a heavier post at 15 pounds. Here you can see upper post number 1, that is a 6-inch by 6-inch by 1/8 inch square tube. You can see the spacer angle that's welded to it, and of course that spacer angle would be on the upstream side where the bearing plate would be resting against it. There's another view of upper and lower post number 1, and you can see there that seat created by the side plates that are welded to lower post number 1, where upper post number 1 would set into. We do recommend when these are installed that driving caps are used for lower posts 1 and 2 so that the load is not applied to the side plates and we're putting the load on the post itself, because we don't want to damage those when they're installed. If that was a little loud on your end, I do apologize. Just wanted to make sure everybody's awake. What you just saw is my how not to slide. You can see there that they were pounding, as you see here, on the side plates. We don't want to do that. And in this photo, they're installing the post with the post bolted. We don't want to do that either. We could damage the connection bolt if we try to install it while it's assembled, and we can damage the side plates if we're putting the load on the post itself. So those driving caps avoid that. And this would be an example of a driving cap that we would use at post number 2. And here you can see they're driving post number 2, avoiding putting the load and potentially damaging those welded side plates. So as you're doing the inspection, you might want to pay attention to the condition of those side plates. If they happen to be damaged or any of the welds are broken, contractor didn't do it correctly, and unfortunately we're going to need to replace those because we don't want damaged side plates in place. Here you can see the assembly of what's happening at lower post number 1. You can see that spacer angle that positions the bearing plate kind of at a negative angle there. The retainer tie to prevent the bearing plate rotation. There's 2 5/8 bolts that are used, one on the upstream side to attach upper and lower post number 1, and the other 5/8 bolt is used to attach the ground strut to lower post number 1. Moving on to post number 2, those are the, you can see the open-ended slot in post number 2, and you can see the bolt, the 3/4 bolt at the base of post number 2 is on the downstream side. So with traffic coming from your left to right, that post would pivot, and many times you'll see that post number 2 just laying down can be stood back up and many times reused. That's not to say it can be reused every time. If you have an angle hit, it could potentially be damaged. So when you're doing the inspection, of course they would want to be inspected during the install, but when these things are damaged, somebody else is going to need to come back there and check the repair, and these same procedures can be used for inspection of repaired systems as well as a newly installed system. And here you can see the ground strut in place. The shorter tabs at post number 1, the longer tabs that have to span the entire width of the post at post number 2. And again, we use a 5/8 bolt at the upstream side of post number 1 and a 3/4 bolt on the downstream side of post number 2. And here you see post number 2 with that 3/4 bolt on the downstream side. When we tested, we did not use a washer at that 3/4 bolt, but if there happens to be a washer in place at the 3/4 bolt of post number 2, that's not a problem. But a washer is not needed. Looking up at the connection of the rail to post number 2, you can see they're using a short splice bolt there. We do not want to use a longer bolt that would pass through the back side of the flange. That could potentially cause a snag on an end-on hit, so we need to be sure we just use that short bolt. This is a universal post that was originally intended for both the 31-inch and the 28-inch NCHRP 350 terminals, because the 28-inch would use the lower slot, and then moving up 3 inches, the 31-inch MGS system would use the upper slot. With the MSKT, you'll recall the installation height is 31 inches plus or minus an inch, so that lower slot is really just a legacy hole that is not technically needed for the MSKT. Here you can see a impact that had occurred on an MSKT, and as we noted, post number 2, this I can tell just by what I see here that this was a very shallow angle impact, because post number 2 rotated, it pivoted. It doesn't look like there's any damage, and quite possibly we could stand this post back up and reuse it during the repair. The rail section within the terminal is attached to every post except for post number 1. The impact head itself is attached to post number 1, but the rail is not. The connection of the impact head to post number 1 is 2 5/16 inch by 1 inch hex bolts. This is the cable anchor bracket, and I had mentioned earlier that we have to have a release mechanism so that the impact head can continue translating down the rail without getting held up on the anchor bracket. And we're doing that by using that special shoulder bolt that you see there. It's a high-strength half-inch bolt, and it has an unthreaded shank portion that the anchor bracket, those notches or teeth within the anchor bracket lock into. So the bolts are tight. There's no torque required, but the bolts are tight, and the anchor bracket slides right onto those shoulder bolts. So what I see here, that is our SKT or MSKT impact head, but clearly that's not the correct rail. There's no 1/2x4 slots in the rail. That's not the correct anchor bracket, and certainly not the correct shoulder bolts. Here's another one, the wrong anchor bracket. So what could happen if the impact head translates far enough and attempts to release the cable anchor bracket? Well, it's going to gouge into it, it's going to lock the system up, and it's going to have a bad outcome. So very important that we use the proper cable anchor bracket, the proper shoulder bolts, and the bolts are properly oriented. We hear so many times that the cables have a tendency to go loose. That can happen for one of a number of reasons. Sometimes if the posts are augured and we don't have good compaction, as the soil begins to settle, the posts begin to settle, they can rotate and move a little bit and cause that cable to go slack. And another thing that can sometimes happen is the cable gets wound up, and it'll unwind over time. So what we're recommending, and this is in our installation manual, we're recommending that the cable is held tight so that it doesn't twist as those nuts are being tightened. We do recommend delineation, and of course during the initial installation we need to be sure that we have a good, clean, dry surface so that our sheeting can provide its intended life. So the inspection itself, you see a steel post system, and here you see a wood post system. This is our inspection checklist. So let's go through some of the systems, parts of the system that would be accounted for during the inspection. Working from top left, we need to be sure that we have the proper rails in place, that the rails are straight, there's no curved rails within the system. There's standard steel posts that are used at post numbers 3 and beyond, or these could be wood CRT posts, as we mentioned earlier. The end rail is a unique 12-foot 6-inch rail. The thing that makes it unique is those 1/2x4 slots and, of course, the 8 holes to attach the special shoulder bolts. The impact head, we'd like that to be parallel with the rail. I mean, you don't have to put a level on it. It doesn't have to be perfect, but we want that impact head to be level, flat and level over the end of the rail. There's never a post bolt attaching the rail to post 1. Again, the rail is not attached to post number 1, but the impact head is. The stub height at post 1 and 2, try to keep that at 4 inches or lower. That's really an industry standard that AASHTO had recognized many, many years ago in breakaway signs. So our industry within the terminals adopted that 4-inch stub height, and we recommend keeping that at 4 inches or lower. And as long as you get your grading right and your rail height is correct, that will just happen. Our special shoulder bolts are a very important part of the system. The 3/4 bolt on the downstream side of post number 2, the 5/8 bolt attaching upper and lower 1 on the upstream side. And our post bolts do pass through the rail, connecting the rail to the post at post 2 through 8. And we never, ever want to see washers on the traffic side attaching the rail to the post. But note, as we saw earlier, there will be washers on both the traffic side and the back side of the shoulder bolts that attach to the cable anchor bracket. I don't want to focus too much on the design side of things, but on the inspection as well as the installation, our theory is the more you know about the terminal, the better you're going to be able to understand if it's applied and installed correctly. So let me first mention that during an end-on impact, the system is energy absorbing, and there's going to be 5 things that are going to happen literally instantaneously within just a very few milliseconds. So visualize a vehicle impacting the end of the terminal at we'll say 60 miles an hour. So you're going to have a vehicle that's going to hit that steel box, that impact head that weighs about 170 pounds, and we're going to begin to accelerate that impact head, sending it down the rail at the same speed as the impacting vehicle. So we accelerate the impact head. As soon as we do that, we're going to break that connection of the head to the post, because remember, the head attaches to post number 1. So we have to separate that connection. We will quickly fracture post number 1 at the ground line. We'll begin to kink the rail, begin to deform that W-beam rail section. And then that impact head will travel just a short distance, and it will begin then to release the anchor bracket from the rail. Once those 5 things happen, that impact head is going to begin to travel down the rail uninterrupted, and will keep chewing up rail and knocking down posts until the energy is absorbed. You can see the parts of the system in place there, the rail, the impact head. The ground strut contributes toward the traffic face impact. And as you can see above here, we're saying a terminal must do 2 things. On an end-on hit, we need to render the end of the barrier safe, but a terminal also needs to provide anchorage. And that anchorage comes into place when it's impacted at or downstream of what's called the beginning length of need, or the BLON. And there is an impact condition I'll show you in just a minute that determines that the terminal from post number 3 and downstream will act just like guardrail when it's impacted under design conditions at or downstream of the length of need point, which again is post number 3 in the MSKT. So what you see here is a 5,000-pound pickup truck impacting the terminal at the BLON, or the length of need point, which is post number 3. This is at 62, but it works out real nice at 100 kilometers an hour when you're looking at it from metric. But here you're seeing that pickup truck being captured, contained, and redirected. So we're really testing the anchorage, as you see here. And it's that cable and that ground strut that all provides your anchorage. So terminal needs to do 2 things: render the end of the barrier safe when impacted end on, and it needs to provide an anchor when impacted under conditions that you see here. So what happens end on? Well, that same 5,000-pound pickup truck, that same speed, 100 kilometers an hour, 62 miles an hour, at 0 degrees in just about a second, brought to a controlled stop. And those 5 things that we saw happen instantaneously, allowing the pickup truck to continue down into your standard post. So right there, that quick, those 5 things have already happened. And here we're just going to gradually send that head down the rail. You see those numbers that are turning, those are frames per second and milliseconds. So we're running at 1,000 frames per second, and we're coming up on about a second's worth of time where the impact vehicle is just about to a controlled stop. Right now, there's a second, and we're just about to a stop. And you can see there's very little damage to the pickup truck. And what that means is the energy that was generated by that crash was absorbed mostly by the deformation of the rail and not so much by the vehicle or the occupants of the vehicle. So from an inspection perspective, we're just trying to get you to a little bit better understand what the terminal must do. So as you're looking at these things, you look around at your site conditions, and you want to be sure that what we just saw on an end-on or a traffic face hit can occur without any obstacles or any grading problems in the vicinity where that terminal is asked to do its job. That's what it looked like after the crash. We introduced this system in mid-2016. So we're about 3 years in now, and there's many tens of thousands of these spread across the country. And we're beginning to, well, for some time now, have been collecting a lot of in-service performance data. And I'll show you just a couple of pictures of what it looks in the real world. You know, we test these products in a perfect world under a very controlled environment. But the real test is what happens when you put it out in the real world. And that, you know, that's where we see how it's going to be able to accommodate all the different site conditions, all the different impact conditions, all the different vehicles, all the different weather conditions. And the MSKT has a pretty good track record, showing you some examples of some of the crashes that we've seen over the years. When it comes time to repair the system, you can see the cross section of the guardrail is not flattened, it's kinked. SKT stands for sequential kinking terminals. So what that tells you is that the throat area of that impact head that the rail passes through, it's fairly wide. So that makes it fairly easy. I never want to say it's easy, but relatively speaking, fairly easy to maintain because of that wide throat. So you're going to want to cut it, keep everything on the downstream end connected, and then you should be able to remove that impact head. If it's bound up or twisted because of an eccentric type angled impact, we can always put a chain on the end of it and pull it off with a pickup truck. You know, we spend a lot of time trying to tell you how to do things correctly, and we've discovered through the years that when you see how not to do things, you know, sometimes that image will stick in your mind, and you know, some of the things that we need to avoid during the installation and certainly as you're inspecting these things, some things to watch out for. There's a term that's been used in our industry for some time now called Frankenstein terminals. And what that really means is we're putting parts of one system onto another system. And one of the most common violations that we see is our impact head on somebody else's rail. And folks, plain and simply, it's not going to work as designed if you don't get all the right parts with the right system. I think this was fairly obvious to see that there's no grading whatsoever, and you could never expect the terminal to perform as designed when you put it in this type of condition. You can probably see the tree there. Again, environmentalists might object, but the reality of it is that terminal is never going to be able to do its job with that big tree sitting right next to the impact head. Nor a fire hydrant for that matter. This appears to be kind of a gore area where you may have an exit ramp or something, or a split between two roadways, and you've got two ends of the rail, and this is not a location where you put a roadside terminal. This is something that would need a crash cushion or a median terminal. You could never expect the terminal to perform as designed with that type of application. This one's pretty obvious. That may be a breakaway pole. I don't know that. Those may be shear bolts. Regardless, if it is a crash-worthy pole and a crash-worthy system together, neither one's going to be crash-worthy. Now, just picture yourself about ready to hit this terminal. You've got that wall on the left. On the right. That as well as that big pole, just can't expect it to do its job in an application like this. The old saying, if it can go wrong, it will. Here somebody got a little creative and put a wood post in upside down and has an interesting location for the cable anchor. Not sure what happened here, but clearly without a bearing plate. And remember, we saw the traffic face redirect hit where that cable gets loaded. On an end-on hit, that impact head will go down the rail, but the problem here is the traffic face impact. You've lost all your anchorage. And then that post bolt number 2, we pointed out earlier that we don't want to have that long bolt, because on an end-on hit, that could have a tendency to bind up the connection and make the release of the rail at post number 2 a little difficult. So we never want to use that kind of a bolt. And then wrapping up here, I again want to emphasize what is available online with our training. And if you allow me, I'm going to take you to our website so you can see what you might expect. Our website all throughout has a link to go directly to our MSKT 3D training. And what you would do, currently there's only one training course on the site. There's another one in development right now, but we'll select the MSKT training, and then from there you would fill out your name, your email, phone number, your contact information, and then you would start the course. Or in my case, I've been on this course before, so I'm going to say click here if you've already started the course. If you are in the course and you have to quit for any reason, it'll allow you to get back in without having to start over, and it'll allow you to pick up where you left off. Or if you've already completed the course and you want to go back and have a refresher or check on something, you don't need to go through the registration portion again. You simply click here if you've already started the course, and I have. So I'll go ahead and put my information. Okay, you plug in your email, you click continue. And this is one of the first screens that you're going to see. This tells you how the course works. A lot of good information in here to give you tips as you navigate your way through the course. I would highly recommend that you read through this before you start the course. It certainly will explain it and allow you to get through some things that you're going to encounter along the way. So let me go directly to, see, if you're just getting on for the first time, you have to start at lesson 1 and complete that entire lesson before you can get to lesson 2. So this is structured. It's a very comprehensive course, but it is structured, so you have to get through everything before you can move on to the next lesson. But because I've been through it before, I can navigate freely. I'm going to go right here to lesson number 5. And this is the segment where I install it. And we showed you some graphics earlier. We're not going to take the time to go through the installation, but here you can see you can spin the system freely in any direction. You can explode the system, spin it that way. A lot of really cool features throughout. So you explore the system, all the components. You have to go through and understand all the components. And then all the hardware, you have to familiarize yourself with all the hardware, a little bit more of the hardware, and then you begin the build it, where you actually have to physically build the system. As we showed you earlier, you just select your parts one at a time, and I'm not going to go through a whole installation, but I will just show you how it works, where I would click post number 2 and I put it where, oh, I'm sorry, that was just a test. That's upper post 2. You have to, of course, put lower post 2 before you can put upper post 2. So let's try that again. Lower post number 2 goes there, correct. So that's the way it works, and you have to build the whole thing one component at a time. And then once you have built it, then you go through the inspection. You have to inspect it. And this is the slide that I showed you earlier. This is telling me the first thing that I want to check is the rail height. And again, this is the same inspection checklist that's in our installation manual, except it's an interactive visual that will show you what the step is and where in the system to find it if you want to inspect it. So here the first thing is we're making sure the rail height is correct, and it shows you where to measure it. The next thing that we're checking is that there's no curved rail within the section. That'll show you where to check it. We're checking to make sure that the end panel is not attached to post number 1. That's where you're going to check that. The end rail panel has the proper slots. The end rail panel is 12'6". The second rail is 9'4½". And we need to be sure that our 3/4 by 8.5 inch hinge bolt is at post number 2 on the downstream side of the post. So again, when you're in this course, you have to go through every one of these steps to make sure that you've installed it correctly, that you're inspecting it correctly before you can get out of this lesson and move on to the next lesson on the actual installation, I'm sorry, on the actual test of the system. So moving on to inspection checklist number 2 of 4. Continuing on, we're checking to be sure the 5/8 by 9 hinge bolt is on the upstream side. We're checking to see that the stub height is correct, no more than 4 inches. That the open-ended slots are correctly positioned, the connection of post number 2 using the correct bolt. That the posts from post number 3 downstream are correct, either standard steel or timber CRT posts. All the post spacing is correct at 6'3", and that we're using the correct blockouts. You know, some states call for 12-inch blocks. When the MGS 31-inch guardrail system was initially introduced, it was with 12-inch blocks only. And as that product began to mature a little bit, more and more states started using it. a lot of the states gravitated toward the 8-inch blocks. So either 8-inch or 12-inch blocks are acceptable within the MSKT. So moving on to the third segment of the checklist, we're checking to be sure that the impact head does not encroach on the shoulder. And as we said earlier, a 25-to-1 flare rate is acceptable with the MSKT. The connection of the impact head to post number 1 is correct with the 5/16 bolts. The bearing plate is correctly positioned with the 5-inch dimension up, the 3-inch dimension down. And again, we're showing you pictures of where on the system to find that, to confirm that. The anchor cable is taut, correctly installed. Retainer ties have been placed over the bearing plate to prevent rotation. And that the ground strut is in place and properly oriented with the correct bolts. And moving on to the final segment of the inspection checklist, the cable anchor bracket shoulder bolts are properly attached, properly oriented. Again, a very important part of this system. On the compaction, many contractors have the proper equipment and they can simply drive the posts. And on the installation of lower posts 1 and 2, we mentioned earlier that we want to be sure that they use a driving cap of some sort, that we didn't damage the side plates. You want to check for those. But we are able to auger holes, but we would just be sure that we get the proper compaction once the system's in place. No washers used on the face of the rail except at the cable anchor bracket. And then the last thing on the inspection checklist is it's in accordance with all specific state DOT guidelines. And then during the presentation and also within the online training, as part of the inspection, we have a little exercise here showing what's wrong with this picture. And then you have to select what's wrong. And just to demonstrate, if I click number 4, it's going to tell me, nope, nothing wrong here. Try again. And it should be obvious that the problem here is that bolt. Post bolt number 2 is too long. Okay. With that, let me bring back my presentation. With that, we're going to go ahead and conclude the presentation, and we're going to open it up for questions. You can either type in your question, or if you are wired for sound, if you have a headset on or a microphone in your computer, I believe we can verbally ask the questions. So at this point, I'd like to open it up for questions. If you're shy and you don't want to publicly, openly ask a question, I ask that you please take down my contact information that you see there, and I will be more than happy to talk to you on the phone, or we can exchange some emails. While we're waiting for questions to come in, I will again note that this presentation is being recorded. We will create a link. We will send that off to Troy, and he will then send that out for everybody to watch again, or those that you work with that weren't able to join us this morning, they can watch it at their own leisure. Okay, the question was, does the training mention the high strength bolts used at posts 1 and 2? We don't get into the details of the specs themselves. We don't talk about M180 for the guardrail. We don't talk about the A325 high strength bolts. We hope that the materials were properly supplied We have good distributors that sell these for us, and I have every bit of confidence that the material that was supplied, if it does come from our distributors, I have every bit of confidence that it is the correct material. But if there's ever a question, of course, I would strongly recommend that you don't be shy. Ask questions. We've got a lot of contact information on our website, as well as you can see here. Is there another question? How many inches can be cut off post 1 and 2 if we hit rock? I'll want to check the exact number, but I can tell you that it is in a perfect world, it's a 6-foot embedment, and we can probably go, and don't quote me on this, but probably half or more than that post can be cut off. There's quite a bit of post can be cut off. The recommendation, if you want to drill directly into the rock, you have to drill into solid rock 20 inches. So whether that solid rock occurs at 2 or 3 inches below the surface, or 18 or 24 inches below the surface, regardless of where that rock occurs, if you can drill 20 inches into the rock, whatever is left can be cut off. On the concrete, the shorter the post, the bigger the diameter of the concrete. And we do have drawings that we can give you to show you how much post can be cut off depending on what size of concrete footer would be poured. Was there another question? Yeah, we get that question every now and again, and it really doesn't it really doesn't matter. It's really not that important. You know, when we talk about things that we have to adhere to, we're talking about a situation as designed and tested, and any of these changes or differences that we see, the first question we have to ask is it going to change the performance? And the positioning of that ground line bolt, it plain and simply doesn't matter whether the bolt and the nut is on the traffic side or the back side. General practice is that we put the nut on the back side as the work is being done on the back side away from traffic. But as far as a functioning position, it doesn't matter. Well, we tried to set this for an hour. We've got about 2 minutes left. Any reason for the different sizes in the bolts at posts 1 and 2? Not really. We did determine that we needed a 3/4 bolt at post number 2, where that part of the work is being done. Keep in mind that at post number 2, that connection is on the downstream side, and that upper post will pivot. So that bolt's going to stay in place, as well as the upper post 2, under many design impact conditions, will stay in place. At post number 1, it's a 5/8 bolt. It's on the upstream side, and all we're doing is asking that bolt to be strong enough to allow the 1/8 inch wall of upper post number 1 to tear out at the hole connection. So I guess the long and short of it is, if a 5/8 bolt were used at post number 2, I'm not happy. If a 3/4 bolt were used at post number 1, I'm not going to get too excited about. But we're calling for 2 5/8 bolts actually at post number 1, one for the ground strut and one for the upper lower post number 1 connection. Okay, timing is everything, and it looks like we have finished exactly on time. I thank each and every one of you for your time. Again, look for an email from Troy. Troy, if you're out there, just want to send a shout out and thank you again for your efforts in allowing us to conduct this webinar and to be the facilitator to make the announcement and pass on the web link. So with that, I'll just again say thank you to everybody. Have a great day, and don't be shy to contact us if you have any questions. We're here to help. Have a great day.